Why doesn't honey expire? Honey is something of an oddity. It, unlike most foods, doesn't spoil over time. In fact, the oldest known sample of honey found in an ancient Egyptian tomb dated back to approximately 3000 years ago. And it was still perfectly edible. What is it then that gives honey this unusual property? Are honeybees wizards and witches who create magical potions? No. To answer this question, we need to understand how bees make honey in the first place. Honey derives from plant nectar, which is a mix of various different sugars, proteins, and other compounds in a water solution. While nectar composition varies from plant to plant and a range of chemical compounds are commonly present, often the dominant sugar is sucrose. This is exactly the same sugar which is found in your kitchen. The varying concentrations of different components of nectar in different nectars is the reason that a range of types of honey are available, depending on which type of nectar the bees have predominantly been collecting. Hey guys, a small request. If you are enjoying this video, be sure to like, subscribe and hit the bell button. Check out my fact page on Instagram which is linked down below. Bees are the key intermediate step between nectar and honey. Worker bees will collect the nectar from flowers and store it in their honey stomach, distinct from their normal stomach. Enzymes secreted from glands are then mixed with the nectar. These enzymes begin the breakdown of the sucrose in the nectar to simpler sugars. Sucrose is what we refer to as a disaccharide. It actually consists of two different simpler sugars, glucose and fructose, joined together. In the bee's honey stomach, the sucrose molecules are gradually split up by the enzymes into glucose and fructose. Glucose and fructose can also be referred to as dextrose and levulose. These two sugars are actually structural isomers as they have the same chemical formula. The name dextrose and levulose refer to their effect on plane polarized light. Due to the difference in the arrangement of the atoms, dextrose rotates plane polarized light to the right while levulose rotates it to the left. The prefixes dextro and levulo comes from the Latin for right and left. Once the worker bee returns to the hive, it will regurgitate. It brings swallowed food up again to the mouth, the nectar solution, and pass it on to one of the house bees who remain in the hive. The house bee will continue the process the worker bee started for up to 20 minutes. It will regurgitate and re-drink the nectar, continuing to mix it with enzymes and breaking it down further. While some of the sucrose will remain, the majority is broken down into glucose and fructose. Once suitable breakdown has been achieved, the house bee deposits the nectar into the honeycomb in the hive. Then another important step in the process begins. Nectar can be up to 70% water, and this water must be evaporated in order to produce the consistency of honey that we are all familiar with. The bees achieve this by fanning the honeycomb with their wings in order to encourage rapid evaporation of the water from the nectar mixture. Eventually, the water content of the solution will drop to around 17%, vastly reduced from the content of the original nectar. The conversion of watery nectar to syrupy honey takes between 1 to 3 days. The water content of honey is a key factor in why it doesn't spoil. At 17%, its water content is much lower than that of bacteria or fungi. Honey also has a low water activity. This is a measure of the amount of water in a substance that is available to support microbial growth. Water activity is on a scale of 0 to 1, with most molds and bacteria being unable to grow under a water activity of 0.75. Honey has a water activity of 0.6. This, combined with the fact that its low water content dehydrates bacteria, makes it resistant to spoiling. Another factor that helps honey avoid spoilage is its acidity. Its average pH is around 4. This acidity is contributed to by a number of acids, including formic acid and citric acid. But the dominant acid is gluconic acid, produced by the action of bee enzymes on some of the glucose molecules in honey. This further boosts honey's antibacterial properties, as many bacteria thrive in neutral rather than acidic conditions. On a final note, you might also notice that over time honey tends to crystallize and solidify. Because honey's water content is so low, it can be considered to be a supersaturated solution of the various sugars. A solution is considered saturated when as much as solid is dissolved in it. Over time, glucose will precipitate out of the solution, forming solid crystals. The honey is still perfectly fine to eat, and this doesn't constitute spoilage. To revert it back to its liquid form, all that's required is immersion in warm water for a few minutes. Well, that's it. The reason why honey doesn't spoil. Thank you for watching and see you on the next one. Bye bye.